All right, so are on to the disc method day 2. Hopefully yesterday went well for you. The only difference of today from yesterday is instead of revolving around the x-axis or y-axis, it may be that we are revolving around the line y equals 1 or x equals 3. But otherwise, it's still the same process. What's going to make this any different is your radius. Your radius will not just be your function value, okay? So for an example, if we have a curve, and let's say we want to rotate it around the line y equals 1, okay? And let's say this is our curve right here, and it's this shaded area. You have to remember every point on that graph has a height of the function value, right? No matter where it is. So wherever we draw our rectangle, and that function value doesn't stop at the line at y equals 1. It actually goes all the way down. And so that's what that's where we're going to have to be careful, is because this is technically the function value of our function is capital R of x. I'm just using that R for radius. So the issue is that's not our radius. Our radius is just this piece, okay, just this piece. And so what you actually have to subtract out is that height right there. In this case would be 1. So our true radius of this solid would be R of x minus 1. So when we go to plug it into our formula, pi r squared times our height, it would look like that for our volume. So let's say this is going from 0 to, we can still call it b. So you will have to, it'll definitely benefit you to draw a picture, okay? So let's go ahead and look at a problem. Okay, so this will be the directions for all the problems today. So if you just want to write it once or not write it at all, that's fine. Find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the line x equals something, y equals something. Okay, so for each one it'll change. So question 1, it'll be bounded by the graphs y equals 2x, y equals 4, x equals 0, and revolved around the line y equals 4. Okay, step 1, graph it. Graph your region so you can see. So y equals 2x is just a line with a slope of 2. It's bounded by the region y equals 4. And the vertical line x equals 0, which is our x-axis. So with those three functions, you can see we get this region right here, okay? And we want to revolve this around y equals 4. So it's important to know where these graphs are all intersecting. So we have this 0, 0 here. We have here 2, 4. Here we have 0, 4. Okay? So since it's being revolved around y equals 4, we want to draw a rectangle perpendicular to it. And since that's going to be in our x direction, because typically if it's around the x-axis, remember that's y equals 0. So this will be in the x direction. So volume will equal pi. Our lowest x is 0. Our highest x to the right is 2. Our radius squared dx. So what we have to do is figure out our radius. So think about your rectangles. How are we going to calculate that height? Or if our rectangle's here, that height. Or our rectangle's here, that height. You can't just say it's 2x, because if you think about it, That's saying our rectangle here, which we know is a height of 0 because it's on 4. You're saying that the rectangle is 4. It isn't. It's 0. Okay. Over here, our rectangle is 4, right? So because we're rotating around this y equals 4, you want to picture your disk like this. Okay, so think about what is that height. And if you wrote down 4 minus that function value, you are correct. And a great way to check that you have it correct is think about what's your height of this rectangle here. When x is 0, it's 4. If I plug in x0 over here into your radius is 4. If you go to the other end, your x value is 2. If you plug in 2 there, your radius is 0, and that is true. You don't have a height right there because it's on the line y equals 4. So that's kind of how you know that you've done that correctly. So you can check some points to figure out which direction that should go in to figure out the height of every single rectangle along that. So now at this point, it's the same thing we did yesterday. I would foil this first. And then integrate with respect to x. And evaluate from 0 to 2. And when we do that, you end up getting 32 over 3 pi. Okay, so that's why it's important to know where the shaded region is, where are your rectangles, how do you calculate that height. Okay? All right, the next one I'm going to have you try on your own. And then you can pause it and come back and check your work, and hopefully you did okay. So, number 2, y equals, so it'll be bounded by y equals secant of x, y equals 2, x is between pi thirds and negative pi thirds, and it's going to rotate around y equals 2. So step 1, draw it. Okay, here's our picture. So you can see that our rectangle is perpendicular to the line y equals 2. So this will be in the x direction. So next up, what we need to do is figure out our radius. So when you're looking at this rectangle, how are we going to calculate that? Or if we draw our rectangle over here, what's going to be the height of that rectangle? Or if we draw our rectangle here, how are we going to calculate our rectangle? So go ahead and figure out what your r is, and go ahead and set up your integral. Okay, so the height of every rectangle will be in the form of 2 minus secant of x, because what you're doing is you have that horizontal line of y equals 2, and you're subtracting the empty space below that secant function. Also, because secant is an even function and our boundaries go from negative pi thirds to pi thirds, you can double this volume and do your boundaries just from 0 to pi thirds. So you guys have seen that with area. That'll work the same with volume. So what I did from step 1 to step 2 is I doubled it, took out a 2 and changed my boundaries. I also foiled my radius, which was 2 minus secant of x. Now you're going to go ahead and integrate. You are going to have to integrate secant, and you're going to have to integrate secant squared. So hopefully you have not forgot those. All right, go ahead and do that. So you're going to power up for your integral of 4. You are going to get your integral of secant x, which is the natural log of the absolute value of secant x plus tangent x. But in this case it will be positives, but let's go ahead and do that until we get that. And then plus the integral of secant squared, which is tangent. And when you plug everything in, you should hopefully have gotten 4 pi over 3 minus 4, the natural log of secant of pi thirds is the reciprocal of cosine at pi thirds, which is 2. Tangent of pi thirds is radical 3 plus tangent of pi thirds, which is radical 3. And that's all we can do. So at this point, we plug it into our calculator, and hopefully you got 4.103. Okay. The next video for this, we are going to do similar, but now we're going to rotate around vertical axes, okay? Not our y-axes, just different verticals. All right, so I will make a video 2 for that, so this doesn't get too long.